Hello, everybody. My name is Todd Zabel, and I'm very excited to introduce Hunter Newby, who'll be providing our keynote today. Hunter's an American entrepreneur, an investor, conservationist, I might add a conversationist, and the owner of Newby Ventures. His primary field of interest has been network infrastructure. And every year that we do these keynotes, we try to bring in something that we believe is, one, forward-thinking, but yet applicable to what we do. And I think that we'll see that through Hunter's talk and his experience. He's the co-founder, chief strategy officer, and director of Telex. He pioneered the carrier-neutral Meet Me room and the development of carrier hotels and data centers in the U.S., leading to massive value creation and economic development throughout the country. Since Telex was sold, he's been and continues to be the founder, developer, investor, and creation of multiple network neutral infrastructure businesses all across North America and the world. I find that talking with Hunter is a profound experience. He's never short of ideas and trends that he tracks. And with that, I'd like to hand it over to Hunter and take it from here, please.
Thank you. Thanks, Todd. Thanks, everybody. It's a pleasure to be here. Not a lot of time. I put some slides together, and I'm just going to jump right into it. But thanks, Todd, for the bio. Okay. So, topic or the title is Beyond the Edge. Todd asked me to speak on this, the future of the internet and internet network infrastructure, most specifically network interconnection. So the internet's a pretty big thing. It's a broad topic. I specifically focus on what's called network neutral infrastructure. So not a carrier. I'm effectively in the real estate business. I came up with this concept of building an environment within a building where networks existed on different floors for them to extend their physical network presence into for the purpose of making it more efficient for them to interconnect. I started doing that in New York City 25 years ago. I know that there's some oil and gas people on this in this symposium today. So if you're familiar with Henry Hub, I studied that for natural gas and looked at creating that in this world. So define the internet. Internet protocol and the internet are not the same. So here's just a couple of things you need to know at a high level, what we're going to talk about. The protocol is a language and the internet is a network of networks. They're not the same thing. So you hear people talk about IP and the internet interchangeably, but you have to discern between them. And at the heart of what the internet is, there are things called internet exchanges. They are the bridge between internet protocol networks to build the basis of the internet. And that should be a capital I, not a little I, because it's the big internet. This is just a very, I don't want to get technical, trying to keep it high level, diagram of how protocols build the basis of the internet, which ones do. It's not all of them, it's not exhaustive, but it's many, all the way out to the different modes of access. We're going to talk about the difference between fiber and wireless. And wireless is, again, a pretty broad subject, but we will touch on some things that are wireless. But this is really important to know because I focus today, my efforts, on building internet exchange points, which is effectively a euphemism for real estate. The point is actually a building within which the equipment resides. And that building is not owned by a carrier or network service provider. It is neutral. I've started many companies and been a partner in many companies, and we've acquired what's known as carrier hotels across the United States. Starting back in 2004, it's the first acquisition that I did of a building in Atlanta, 56 Marietta Street. Within that, there's a room. It's called a Meet Me room. It's a term that was developed over time in the industry. I was one of the people that created that, many of the terms that exist in the industry. The room within the building where all the networks meet is called the Meet Me room. That's what people actually call it that. And it's under the much broader umbrella of data centers. I won't focus any of my time on talking about those, but they're different real estate elements, let's call it. And within these Meet Me rooms today, there are what's called internet exchanges. And an internet exchange is an actual piece of equipment. It's what's referred to as a layer 2 on the OSI model. Ethernet switch, probably heard the term Ethernet before. It facilitates VLANs or virtual local area network connections between these disparate IP networks. Okay. Again, not trying to be too technical, but I focus on the real estate aspects of building those facilities to house internet exchanges. Just real quick, communication timeline history. Todd asked me to put this in. I want to point out, starting with just basically people talking, two people talking, and then you go through, petroglyphs and cuneiform text and everything throughout history, all the way up to present day in the iPhone. So we're talking about several thousand years of communications. And this is really to represent, there's been different modes and methods over many, many years, centuries, millennia. And this is about where we're going. So how internet exchanges play a role in the internet today and where we need to go with more of them, how we get there, how long it takes, what's it going to cost. Okay, so along the lines of where are we going, there is a resource in the world. It's a publicly accessible database called Peering DB. Peering is a term that's used to define what two IP networks do when they agree to interconnect with each other and exchange IP traffic. There's a few forms, commercially speaking, of peering. There's free peering where they exchange the traffic at no cost. There's paid peering, and then there's something called transit, which is basically buying internet access for the full internet routing table. These peering points are euphemisms for internet exchanges. And this Peering DB database is something that people that are, in the industry, pretty hardcore, use it to find where internet exchanges are and then how to get connected to them. I had my developers build an API into Peering DB to extract the data of where these exchanges are, to map that against a series of articles I wrote almost 20 years ago about where the meet me rooms in the United States or North America were. And I wanted to revisit that and see where internet exchanges were in relation to those original meet me rooms that I profiled 20 years ago, roundabout. And then I took the inverse of that information, as you can see here in terms of the numbers on the states, to determine where internet exchanges were not. So the map of the US here, and I've actually just updated this morning, and I'm going to pop off onto my website to show you this in real time. This reflects how many internet exchanges are in each state and which states do not have an internet exchange at all. So most people don't know how the internet actually works. The internet is most efficiently and effectively routed through these exchange points. Many states lack an internet exchange entirely. And that means that every bit of traffic bound for the internet has to leave their state to go to another state to come back to them. That creates time and cost problems. So latency in terms of the performance of the applications, and cost, because there's usually multiple hops to get there and you're always paying someone for that, which is why it's called transit. So where are we going? What I'm focusing on now is building internet exchanges in the places that they're not, which means I need to get land. I need to build buildings. These are modular buildings, typically the ones that I design and build, a couple thousand square feet. They're typically N+1 power, UPS generator, that sort of thing. It's going to reduce latency and costs, which saves time and money. A big driver for this is the need from both sides. I work with universities and cities predominantly within these states, but they know that they don't have good access to the internet, and they've lived with this problem for a long time, a couple decades. And this is the first time that they've ever had anyone explain to them why they have that problem. And it's represented here in this map. And I can prove it and I can fix it. And I'm working with a nonprofit called Connected Nation. They're a 501c3. They're the largest nonprofit in America focused on rural broadband. And we formed a JV to build these together in these places. One of the big drivers, besides bringing content closer to the eyeballs and people, is cloud access. So also working with AWS and a group called Outpost, and the other major cloud providers have their own, but I'm working with Outpost to help them get closer to these places that lack direct access, not only to the internet, but to the cloud. And I'm just a landlord. I'm just a simple landlord guy that likes to charge rent. I understand how all this stuff works, but I don't do it. I'm a landlord to the networks that do. And then, of course, all this enables IoT, which is another thing Todd asked me to touch on. Not enough time to really get into all of it, but just imagine that all the people and the machines and the devices and everything that connects to the internet, the farther away it is from the core of the internet, which would be many of these states that have many internet exchanges, it performs better when you're closer to the core, and it does not perform as well when you're further away. It's pretty simple. Yeah. Okay. So there's all that. And like I said, I'm going to go over and show you some real-time data, and I can drill down into some of this stuff, particularly if anybody has any questions on it. This is my forte. This is what I focus on. But again, in keeping with where are we going, this is an image that depicts Starlink. Wow, it's a big conversation. Starlink is very important. It's a military operation that has commercial uses. It's born out of SpaceX, which is related to Space Force. And what can I say? It's super important. There's certain applications that are going to run over Starlink that are part of a later part of the discussion that we're going to have on supply chain. So I'm not going to get too much into it now, but it's very real. It's very relevant. But the latency aspects and the capacity and throughput aspects of satellite in general, I don't care which band it is, or which provider it is, at the moment cannot compete with or be better than the performance that wavelengths in fiber can provide. And for the moment, that means that terrestrial facilities that are hubs of interconnection, which is what I'm involved in, are still very much in demand and relevant and needed, and we need lots of them. Just to speak to that for a moment, on one of the applications that I was discussing with Todd, there's connected car, and then there's autonomous driving vehicles. And autonomous driving vehicles is its own category, and I don't speak to that. I'm certainly not an expert in it, but I understand the requirements, somewhat latency sensitive requirements. Connected car is a different thing. And I am familiar with connected car because of my relationships to some of the internet exchanges, particularly the largest one in the world, DKIX, based out of Frankfurt, Germany. And I'm privy to what some of the car companies want aspirationally in terms of connected car. And just to understand what connected car is and what it does, the car companies want to collect data, not just from the car, but from the people that get in the cars. So people and devices. So people get in the cars, they have their phones and their tablets and whatnot. And as soon as they sync to the Wi-Fi or the Bluetooth in the car takes every keystroke that was ever made on that device, and it's called a phone scrape. It takes all that data, and it stores all that data, and slices the data up, and they monetize that data. The car companies want to get that data as fast as they possibly can because it's valuable when it's fresh, kind of like bread. And it's more valuable when it's fresh, less when it gets stale, data gets stale. So I read an RFP from one of the big US car manufacturers. This is a few years ago now, just before the whole COVID lockdown situation. So I don't know how far they got into it, but what was particularly relevant and salient to me was the latency target that this car company wanted. And they wanted to collect the data and process it from every car on the road that they manufactured, from every device that's in every one of those cars in sub 1 millisecond across the country. Sub 1 millisecond equates to 50 miles or less. And based on this, you need exchange points in a lot of places to pull data from the mobile operators and process that data. So you need switches, you need routers, you need servers in a lot of places in order to get to sub 1 millisecond. And satellite won't be able to get to sub 1 millisecond. It's at least a couple hundred milliseconds up and down. So that's why I wanted to touch on that. But the sub 1 millisecond from a cell tower radio to switch to a router to a server to process that data and then effectively, whatever, monetize it, let's call it, would require a great deal number of more exchange points than what we have today. I mapped out sub 1 millisecond on a 50-mile radius basis, and effectively in a neutral setting with multiple cloud providers and multiple transport providers and the MNOs all working together and agreeing this would happen, you would need 22,000 facilities across the US. Not big, but effective. And we're nowhere near that. So just wanted to touch on that. That's not exactly what I'm doing this for, but it's part of it. And a lot of these applications, they may work in some places where there's good coverage, and they won't work in other places at all because of the latency. Again, distance equals time, and sub 1 millisecond is unrealistic. And you also need the mobile operators to play ball with that. And as far as I know, that they haven't decided to do that yet. At least not in the way the car companies wanted. So it's a lack of infrastructure, broadly speaking, in a neutral sense, and it's going to require a lot of capital to build, which is a big need, and that's part of the supply chain conversation. Okay, so back to the Starlink thing. Again, super important. Latency is an issue, throughput's an issue. It has its own applications. It's great, commercially speaking, for areas that don't have any connectivity at all. But for, like very high capacity, very low latency requirements, I don't think that it's going to be there anytime soon. And then finally, where are we going? So back to the original timeline slide where I had two people talking, where we're going is telepathy. I tell people that, I've been telling people that for 25 years. The biggest threat to what I do is what I refer to as internet telepathy, and people sort of laugh. I said the day that two people can communicate with their minds, we probably don't need all this fiber or as much of it. And I said that almost in jest, but I was serious. And now Elon Musk, is rolling out Neuralink, and he said at least initially it applies for people that have, physical impairments that they can't control movements and such. But he's certainly leaning in, let's just say, and hinting towards what the future of communications will look like. And this is in that future. How soon? I'm not sure, but it's in the future. So it's worth a slide. Okay. What people need to think about: change is the only constant. Okay. The need to communicate never changes, only the method. And we're going to see technological advances, I think, in the next 10, 15 years that weren't even comprehensible. You couldn't understand what's about to happen. No one, would have even imagined. I'm also invested in blockchain. I like blockchain a lot. It's synonymous to internet protocol to me. There are certain applications above it, which you would sort of say it's like an app or a website, like an NFT, for example. And there's a whole lot of innovation coming out of that space as well. But at the root of it all today, we need more physical infrastructure to make it all work. Okay. And I have a Q&A slide. How are we doing on time? About
doing good.
Yeah. So Todd, if you want, I could toggle over to the site and give people a little deeper dive on the exchange point thing, or we could.
Why don't we do that?
Okay, fine. Let's do that. So, all right, this is my site, Newby Ventures. We could send links around to everyone if you want after this is over. This is my research page, specifically to the internet exchanges by US state. This is updated as of November 8th. The map was updated. Here we can scroll through all the states and see.
Yeah, Hunter, I don't know if you're showing if you're showing the site. You might only be showing the slides on the share screen, maybe.
Hold on.
There you go.
Yes, sir. Thank you for that. Can you see it now?
There you go. Yes.
Thank you. Okay, I'll repeat myself. This is my site. It represents the different deals that I'm in. This is the research page, which is a continuation of everything that I've done. I guess that we're wearing my journalist hat. This is the mapping, which is more recent, updated the map itself. internet exchanges by states. You could see, you could scroll through here. This is actual live data. This was pulled yesterday. Yeah, so I use this to know where to go. This is my compass, so to speak. And then this is the series. This is the exact order that I did the original series: New York, Los Angeles, Atlanta. Just published Atlanta today, but we'll go back to New York. I found some bugs with PeeringDB itself that I had to get them to work on to fix. So my developers and them worked together over the past several months to do that, because nobody ever tried to do this before. So some of the things that I was asking for were alien. There's a brief intro here to the original series, the then part of it, which is a recap of what these cities were like back in 2003 and 2005 when I covered them. And then there's the updated version now, where I focus on internet exchanges, which is a relatively new development in the network infrastructure landscape in the world, not just in the US. And then I focused on just the exchanges that are in New York. I point out that it's a little ironic that New York encompasses New Jersey, but people still refer to it as New York. And I said, it's not that alien. If you're familiar with the New York Giants and the New York Jets, they both play in New Jersey. So there's a lot of New York internet exchanges on the other side of the river. And then here we go. This is the fun part. So in general, carrier hotels across the world are known by their address. 60 Hudson is one of the most famous. Out there in LA, you got One Wilshire. Up in Seattle, you got the Westin building, which is known by its name, not its address. This lists the address, the number of exchanges, and then the individual facilities within that building. And then it shows you the internet exchange and the number of ASNs that are on that exchange. An ASN is an autonomous system number, which is an address for an IP network. And I'll get into that in a second. DKIX is based out of Frankfurt, Germany. Very good friends with them. We do a lot of things together. They were a tenant of mine in a couple of my facilities here in New York that I've now exited, but they're still there. Anyhow, it shows you all the exchanges, all the ASs, and then what actual addresses they're in. I used to own that building there, 325 Hudson. This building, 60 Hudson Street, is where myself and partners started Telex, which was the first neutral interconnection facility business at 60 Hudson Street. That's over 20 years ago. The reason why I wrote these articles is because I wanted to go back to see if the largest internet exchanges in these cities today were the meet me rooms that I featured 18 years ago, and lo and behold, they certainly are, which wasn't a shock to me. I actually knew that that's what was going to happen. It's like network gravity. So critical mass begets critical mass. And all of those facilities have done nothing but continue to grow over the years, and more networks come and connect in those rooms, in those buildings, on those floors, and now on these internet exchanges. And you could see how, significant. I mean, it starts to get thin pretty quick, and a lot of that's in New Jersey, but there are several sites there that, are very dense. Now, the AS numbers, okay, so we're going to go to the archive. I'm working on the live data update for sorting right now, but this shows you the AS number of the IP network. So Hurricane Electric, for people who've never heard of it, if you're outside of the industry, you wouldn't know, but Hurricane Electric is an ISP, and they also sell transport, Ethernet transport. And they have some data centers. They have one in Fremont, California. But they're the largest IPv6 network in the world. And then, of course, you have, brand names that you'd know: Yahoo, Cloudflare, Facebook, Google, Microsoft. And you could see how many internet exchanges they're connected to. That AS is connected to this many IXs in this city, in these locations. Why is that important? Because when you are building your own network, your own IP network, you need to get connected to other IP networks. And if you're not just going to buy upstream transit from, AT&T or someone like that, you need to know this information. You need to know the biggest networks in the world, where they are in that city that you need to connect to them in. And then you could literally click through this and go to the facility page for the network. Let's see, I'm just going to randomly do this right now. Digital Realty, there you go. My company Telex was acquired by them. So this is that facility at 60 Hudson Street. And these are the AS numbers that are there physically in that site. And these are the internet exchanges that are within that facility. Digital Realty is a data center REIT. They're publicly traded. You probably have heard of them. If you haven't, look them up. They're public. You can read all about it. This is interesting too. The Big Apple Peering Exchange is an exchange that I actually started over 20 years ago with a friend of mine. We're not really paying much attention to it, as you can tell. It's still there though. I should say he isn't. And DKIX New York, obviously the largest there with 244. Anyhow, this is the world that I focus on. These are the things that I do. I am presently working with Connected Nation, as I said, to build internet exchange points in many of the states here that have zeros. Myself and Connected Nation actually helped to draft the IX bill, which is the internet exchange bill that was passed by the House and the Senate, and it made its way into the Middle Mile grant, which the deadline for that was September 30th. So we applied for 5 internet exchange points to the grant that we helped write. And we worked with 4 universities and 1 city, University of Kentucky, Mississippi State, Oklahoma State, and Wichita State University, as well as the city of Albuquerque. We submitted that grant. They're each donating roughly 2 acres of land to us. The universities will do that on their research campuses, and then the city of Albuquerque on their airport, they decommissioned a runway. And we're going to build these modular buildings, and we're going to bring in DKIX through a JV relationship I have with them to those facilities to localize content and then bring the cloud into those places, which you can see there. Those states need some help, and they're aware of it. So we're happy to be doing that. And we have a total of 124 cities on our list that we've profiled using many data points that lack an internet exchange and an internet exchange point. And then through Connected Nation, they know how much every school district in the United States pays per megabit for transit. So that's kind of like a treasure map. And we use that to triangulate all this. And then we approach, flagship institutions and local governments to work with them to help solve this problem. So with that, I think I'll stop and just, pass it back to you, Todd or Kristen, and see if you guys have any questions or anything else you want me to cover.
Yeah, we've got a couple minutes left and a couple questions that have come in. First one is maybe I should start the video here. How, Hunter, will this impact our business and our business models? Is there something here that we should be looking at or considering?
Yeah, well, any company that uses the internet that has operations of any type in any of these states, first and foremost, if you're using the internet or internet protocol over your own private networks, you should have a presence in one or more of these existing internet exchanges without question. And if you don't know what an ASN is, I've got a couple of links that I could share with you it's a tutorial, it'll make sense. That helps you reduce cost and helps you reduce latency, which improves performance on your network, in general. And then if you're operating in any of the states that don't have an internet exchange, let's have a conversation, because I'd be really happy to work with you to help improve the network performance of those operations in those states as I go along with Connected Nation to resolve this issue of eliminating all the places in the United States that don't have the internet.
Yeah, I would think that some of our energy friends are probably looking around a couple states there where they have operations and are going to be doing more and more with IoT linked to their assets, and probably concerned that some of those states don't have anything at all or only have one,
right.
Which is very interesting. Okay, another question that came in is, how should we be thinking about things differently, if at all? Is there something here that's going on? You mentioned Starlink. You mentioned IoT. are there things that people should be thinking about as this all develops over time?
Well, the lack of internet infrastructure is a problem that's existed for a long time, and people call that the rural broadband problem, but it's not really rural, it's an American problem. There are third world nations everywhere within the United States. But that's a system structure that is broken almost intentionally. And there's a bigger thing that everyone should be thinking about that's going on that we'll talk about later in the supply chain discussion. But as it pertains specifically to networks and the internet and using the internet to do, your business, whatever it is. Yeah, this is something that you should all be thinking about and be, asking questions about, certainly at a state level, but being privy to this information helps you make better decisions about how to build and run your networks, which pretty much every business of size today relies on networks. I mean, we're doing this whole symposium over Zoom. So if we didn't have good networks, this wouldn't work. That at a macro level, I think that's just knowledge and it's actionable. The capital aspect to it, which is what we're going to talk about later, supply chain, the supply of capital. What is that? What is currency? What is money? That's super important. It's almost the biggest issue. It's right below the biggest issue. And that impacts this because as great as the data center market generally has been in terms of network infrastructure in the past few years, it's been fueled by, just endless printing of the Federal Reserve, fiat, very cheap debt, which has all changed just in the past few months. We have interest rate hikes. We have supply chain issues that are impacting costs and time. And it's going to become ever more so challenging to fix this problem right here with these states that have zero. It was hard enough to attract private equity to come build or acquire a site that already existed for strategic reasons or whatever. They want in place triple credit tenant customers, cash flows, EBITDA. Trying to get them to invest in greenfield in places where there's nothing is very challenging. I know, I've been doing this for over 20 years. Now it's going to get harder because the money problem, is broken and getting worse. When we're on the other side of that, hopefully very soon, but I don't know how long, I don't think that this will be as much of an issue, but it's what do you do about it right now? And how is it going to impact your business performance right now, both on the internet network infrastructure and then cost of capital, access to capital. I think that's everybody, valuations. I think about that every day. It's what drives us. It's what we're building equity value for, the exit, right? One day. And what's that going to look like? So those are the things that are on my mind as I invest in this and build this out. And, that's
right. We got to wrap this one up, but Hunter's going to be back later. He's got a passion for some elements, the supply chain that we're going to talk about. But I want to thank you, Hunter, and look forward to you coming back on after not this next one, but the following one.
Okay.
Where we're going to talk about some very interesting things around supply chain. All right. Thank you again, Hunter.
Thank you.